Good afternoon. I'm Dr. Crispin Pierce. I work at the University of Wisconsin-Eau Claire. Really want to thank you all for coming today. I want to share a little bit of what we've been doing in the last 10 years in terms of looking at air quality around frac sand facilities. We felt it was important to do it because there was some data gap. We didn't have, I think, as public health professionals, a good understanding of what's present. So we have done some monitoring, we've done some work. We published 2 papers. The recent paper is up here if you'd like a copy. It's full of all the details of our work. And our aim today is to present some of this work and also to talk about a new phase of monitoring. These new purple air monitors that look a little bit like this. We think that there's still a lot of information to be gained. I think information that could be valuable to citizen groups, people who live around frac sand facilities, to frac sand manufacturers, to people in WISA. We think it's all valuable information, so we're hopeful that at the end of today, and you're welcome to ask questions at any point, there'll be a better understanding of the work we've done and the directions we want to go and how you might be a part of that. So that having been said, I'd like my students to actually introduce themselves. Busting a few buttons here, a little bit proud because they're really fine UW-Eau Claire students and they've done most of this work. So, if you will, please.
Well, thank you all for coming. My name is Orion Hallgeier. I'm a junior environmental public health major, and I've been doing this for about 2 years with Crispin.
My name is Connor Bynes, and I've been on the project for about a semester now.
My name is Aaliyah Anderson, and I've been on this project for about a semester.
My name is Alex Larson. I'm a junior environmental public health major, and I've been on this project for about a few weeks.
Throwing it right into the deep end. So we'll kick things off. We'll talk about particulate matter, sort of what it is, the very basics of it, and then we'll get into sort of the next steps that we hope to take with the purple air monitors. We'll kind of transition from there into some of the instruments we've used in the past, some of our analysis instruments. Oh, yeah. Some of our analysis instruments, and then we'll kind of transition back into some of our publications. We have one up here and one that was published a couple years back. Some of our past research, some of the more recent interpretations we've done with it, and then we'll kind of get into some background sampling we've done in Augusta and in Albertville, and then we'll kind of wrap things up with the future direction. I have questions and comments down here on the bottom. Feel free to raise your hand, shout out. We're here to answer as many questions as we can. So.
So we are looking at the generation of particulate matter, especially in frac sand mining. This is the kind of particulate matter that can contain silica particles, and these can be hazardous to humans when they breathe it in. In Wisconsin in general, louder. In Wisconsin, 100 million tons of sand per year is extracted for use in hydraulic fracturing. Most of the sand being used is made up of quartz crystals, which is silica sand. And through the blasting, loading, and hauling, and through the manufacturing processing of the silica sand, the industrial silica sand, it gets aerosolized, and these particles can be breathed in by humans. The focus of this research is to study the levels of fine particulate matter and the health risks that people exposed in the areas near the sand mines and other mining operations. These are the particles that we're looking at, PM 2.5 and PM 10. PM 10 is the larger of the two. This can be found in dust, pollen, and it's usually easily coughed or sneezed out of your respiratory system. The PM 2.5 is a lot smaller, and this is the kind that when you breathe it in, it can go deep into your lungs, and it can get absorbed into your bloodstream. The PM 2.5 is defined as fine particulate matter, while the PM 10 is defined as the coarse particulate matter. So some health effects that this particulate matter can have, it causes respiratory conditions such as an irritation in your airways, so coughing, sneezing, trouble breathing. Some conditions that can develop with that is aggravated asthma, chronic bronchitis, irregular heartbeat, non-fatal heart attacks, and sometimes premature death if it develops into lung cancer or heart disease. The factors that play a role in this include like exposure, duration, and the size of the particulate matter. The two determinants that we're most concerned about is the exposure and the size of the particulate matter.
Okay, so the instruments that we use to do our air quality monitoring are the purple air monitors, our DICOT, the DPS, Dust Track 2, the Dialos, the Con Microbounds, the BGI, Petrical, and the WeatherLink Meteorological Station. The purple air monitors have presented a wonderful opportunity for air quality monitoring accessibility. These reasonably priced monitors have dual laser counters that collect particulate matter concentration data of sizes 1, 2.5, and 10. They also measure humidity and temperature. All of this data can be uploaded and accessed on a user-friendly website. So how trustworthy is the data collected by the PAM? Well, the Air Quality Monitoring District of the South Coast has performed a field evaluation on the PAM, comparing it to federal equivalent monitors, the BAM and GRIM. The results are very promising, as the R-square value between the PAM and BAM PM 2.5 comparisons was greater than 0.86. With the GRIM, it was even better with an R-square value of 0.93. Now, the PAM requires an internet connection and power source for there to be continual data updates in real time to their website, purpleair.com. However, there is also a PAM with an installed SD card that stores data, and you can manually update it or upload that to a computer. This is a great solution for those without a Wi-Fi connection. If power sources are unavailable, there are portable power generators on the market, and some can even use solar energy to provide the power needed for the PAM. Okay, for people interested in the PAM system, but they're concerned about their privacy, there's no need to worry, because only the location description is used on the map. So your name and personal information is never used. There's also an option to set your account to private, so that none of the information can be accessed by anyone else but you.
All right. So the graph that's listed right here shows the multi-capability of the PAMs. So they can measure PM1, PM2.5, and PM10 concentrations. And you might notice that the PM10 concentrations are a little bit higher than the PM2.5 and the PM1. This is something that we would generally expect because the concentrations of the PM10 includes that of the smaller particle sizes in addition to the PM10 sizes respectively. And this graph here shows a purple air monitor. It has two dual sensors on it. So this is over a period of about 2 months. And we see the general same trend line from each of the PAMs. But this kind of had our research team thinking about the accuracy of the purple air monitors. We wanted to go into this with accuracy being our #1 goal. So that being said, after we heard about the South Coast AQMD field evaluations of the purple air monitors, we started thinking about a corrective formula that could give us a more accurate result from the purple air monitors. And if you look at the equation that's here on this graph, this is called the linear regression formula. There are 6 like this over a 24-hour mean for both the FEM-BAM and the FEM-GRIM equipment. So our team utilized these equations and took the average of them all to gather one singular corrective formula in order to give a more accurate representation of what the PM2.5 might actually be at any given time. So that being said, once we got to graphing, we found that the PAM outputs, when they're at a higher output, our formula corrects it to be a little bit lower. And when it has a lower readout, like right over here, our formula actually corrects it to be slightly higher. So after we started analyzing our formula, we started thinking, are there any other scientific communities out there that have done this similar research? And we ended up finding 2 of them. So the first one that we found was the University of Utah, and we found that they had a very similar corrective formula to ours, which was quite promising. So if you notice over here, they had the same trend with a high readout correcting towards a little bit lower, and then with a low readout, it corrected a little bit higher, which was something that we were looking to see in the formula for accuracy's sake. And then the second place that we found was the Lane Regional Air Protection Agency in Oregon, and they had the same general trends, but they ended up having a little bit lower of output data, which kind of surprised us. So we got in contact with LARAPA as to why it might be a lower PM2.5 concentration, and we were informed that they believe that it's due to the combustion of wood that's really common in the West Coast area. Their conclusion was that the wood being carbon-based is more reflective on laser sensors than the crystalline silica, which ends up giving the PM2.5 a higher readout with the PAMs. Yeah. All right. So now I'd like to talk to you about the other instruments that we use in a little bit more detail. So there's three basic categories. We have our filter-based instruments, our spectroscopy-based instruments, and our analytical-based instruments. The first filter-based instrument is right over here. So that's a federal reference method. So that's what our government uses as a reference. And then that's the Anderson dichotomous sampler that uses our filters that we're actually going to be handing around here. So we use that in conjunction with one of our analytical instruments to measure pre and post weights. And then we utilize an average of that to determine PM2.5 concentration levels. And then our second monitor here is the DPS, or the deployable particulate sampler. And then as far as our spectroscopy instruments go, we have our DustTrack 2 and our indoor Dylos DC 1100 monitors that we use. And our analytical instruments include the BGI Tetracal, which measures volumetric airflow for calibration of our instruments, and then the Con microbalance, which can measure mass down to 1/10 millionth of a gram. So it gives us a really high level of accuracy. So now I'm going to hand it over to Orion, and he's going to talk about our publications.
Yeah, so, and we also do have a DustTrack 2 here with us. So, this is what the DustTrack 2 looks like. It's a spectroscopy-based instrument. It utilizes sort of it has a laser on the inside that sort of counts particles depending on their size. So bigger particles refract more, smaller particles refract less. And then we can do a little demonstration with that. Yeah? Let's see how far this cord can get out here. Try and put it out front.
And then we've got some filters passing around. If you look on the outer edge, that's what it would be clean before any sort of mass. Some of them are dirtier than others. The inside of some of them are pretty dark. So you can kind of see the respective change after exposure.
So here we have whole sand and we have frac sand, like silica sand. And we can get readings from both of these if we shake out the bottles so they aerosolize in the air when we open it. And the DustTrack 2 will tell us how much it is in micrograms. Is it micrograms per cubic meter?
Milligrams. Yeah.
Well,
Yeah, but I'll convert it to micrograms.
You can kind of see the powder that floated
Yeah.
off. Yeah. And it was at.
Oh, I didn't start that time.
Run it again. Yeah. So it was.
There we go.
Yeah, it was at 2 micrograms, and it's up to 222 just from shaking that up and then inverting it, letting some of the dirty air come out.
Yep, and then we can.
Kind of hold it up, and this is what it sounds like. A lot of these instruments, they take up a good amount of air, but they are quiet. The filters that were passed around were used on our FRM instruments, what we consider to be, what the EPA considers to be the federal reference method. So those are used in our dicot sampler, and then I may have passed around one bigger filter, that would be the DPS filter. And so we see a value in using a sort of assortment of instruments to make sure that they're all carrying along similar trends, to make sure we're getting viable results along each sort of step.
And as we try out the frac sand, you get less of a reading because of the finer particles in frac sand. It's harder for the DustTrack to read. That was about 0.011 milligrams, so that's significantly less than it was for the whole sand. The DustTrack has trouble picking up the finer particles in the frac sand.
well, so why is it? So tell us, Alex, these are two different sands. One is the whole sand we would dig out of the ground, and one is the sample of the frac sand after it's been refined for use in hydraulic fracturing. tell us please about the difference in the particle size composition in whole sand right out of the ground and after it's been refined and how the dust track reflected that.
Yeah, the whole sand has the PM10s and the PM2.5s. You can see that when you can see some of it coming off of the aerosolization of it. The frac sand has more of the 2.5 particles because it's finer. It's more fine particles.
So let's talk about that a little bit. Frac sand, the larger particles, of course we have experts in the room who are even better at this than I am. The larger particles on the order of 500 micrometers. They're valuable in hydraulic fracturing because of the size and shape. So after the sand has been refined, it's the larger particles that are left. The smaller particles are called waste sand. So in here we have all particle sizes, and Alex, you can actually, we'll pass these around. You can look, if you see the tops of these vials, you can see that the finer particles are accumulated on the inside here, much less so for the frac sand. So all particle sizes, and then the much larger particle sizes that the frac sand industry uses for hydraulic fracturing. So what does that mean about what we just saw then, Alex?
The dust track too is able to pick up the whole sand and give us a more accurate reading than it is for the frac sand.
Yeah, and it measures the frac sand too, but the frac sand has all the small particles removed. So when we're looking at PM 2.5, there's much, much less PM 2.5 left in the product, or the actual frac sand that's sent to the Dakotas or back east for fracking. So we saw quite a bit of difference in the things we're concerned about, much more in the whole sand, much, much less in the refined frac sand.
Yeah, and just to add to what Dr. Pierce said, these are just very small particles that we're working with. PM 2.5 able to fit a number of them in a PM10 particle, and then even if you reference that to the diameter of a human hair, many PM10 particles to the diameter of a human hair, and then a fine beach sand as sort of a grain of fine beach sand as reference. So these are just very, very small particles, some of which we can't even see. So when we opened up the waste sand, you could see some of those, you could see that. The particles that we're measuring, in some cases, we can't even see. And that's why, as Connor said, having a scale that measures so specifically to 1/10,000th of a gram is very vital, just because it can get those different mass changes and can quantify the amount of particles that are in the air. And so we've been published in the past in the Journal of Environmental Health. This is us on the cover. In this paper, it kind of talks about 6 sort of pilot samples we've done over a 24-hour period, with levels of PM 2.5 ranging from 5.82 to 50.8. And then our publication that's up here, and we have a number of them available for anyone who'd like to grab one, published this year in the Archives of Environmental and Occupational Health. It talks about the 2 years of sampling we did in New Auburn and Bloomer, and then some of our more recent work doing some of the human health implications of it all. So we have copies of that available front as well. And so here, probably a little bit north up here in Chippewa, we are right now. We've done some work in New Auburn and Bloomer, Wisconsin, and then we use the DNR as sort of our background air quality site. We use the one in Eau Claire because it's the closest regional one that we can find background data. There's a number of them across Wisconsin. I believe there's one in Madison and Milwaukee. But this is the closest one to all the work we've done in New Auburn and Bloomer, and then again in Albertville. But you can see the mines right here with those pickaxes and spades, and then the processing plants in yellow. And it's just important to note the sheer quantity of mines next to one another. And it's been interesting to see that kind of effect. So in Bloomer, Wisconsin, our equipment was in that green dot right there, and then the red dot, mine just about a mile north. Here we found an average PM 2.5 concentration of 7.7 compared to the DNR's background of 5.11. At this site we sampled from October 20th, 2014 to September 21st, 2016. So it was about 2 years of sampling there. When we go to the graph, we used our FRM instrument, so that was the dicot that used those filters that we passed around. It was the dicot that is the FRM instrument, a filter-based instrument that we used to make these graphs that we based our publications off of. So you can see our values in blue, and then the DNR background stuff, or the DNR background levels in red, compared to that 12 microgram per cubic meter average, the annual average of the EPA set as a safe level. And here we can see some spikes above. We can see a general increase above DNR background levels. However, we're seeing a little bit of an increase above background levels. Overall, though, over the 2-year period, it was not a significant increase, and it's still below that 12 microgram per cubic meter EPA set background, or EPA set safe level. And then we have PM10 data from our FRM instrument here as well. The DICOT can sample PM 2.5 and 10. It's got 2 different filter cartridges where you can put 2 separate filters for each particle size. The DNR did not take PM10 background levels, so we plotted this just to kind of make sure that our PM 2.5 levels match spikes in PM10, because you'd expect to see those increases consistent across the board.
Can I ask?
Yep.
You had that was one monitor in one spot. Can I ask how
Yep.
you chose where to site it?
Yep, so we followed EPA siting criteria. At the time, we put it at the closest spot we could. So where we had access to power, we followed, when we put our instrument, we followed the EPA siting criteria. And then we put it as close to the mine as we could using the methods set by the EPA to do so.
Did you try to correlate readings with the prevalence of the wind direction as well?
We looked at wind direction and found that there was no significant increase north, south, east, or west of the mine. So we did not see a significant effect from precipitation or wind speed. And that's in the publication as well.
Were you surprised at that?
We were surprised at that, and it's still something that we question today. One of the things that's nice about the purple air monitor is that it gives us weather data, gives us humidity, and we can kind of look at these effects across the board between PM 2.5, between PM 10, PM 1, and see how these weather events can affect the levels in the air. We were surprised to see that, but these PM 2.5 particles, as you can see in that picture, they're very, very small. We found, and the experts in our field have said it's like herding cats. They don't travel in a predictable manner. So that's something that we've kind of observed firsthand, is that we don't necessarily know in a predictable way how the wind would affect these particles because they are so small.
I'm kind of a novice, but I noticed on with the charts that there were some serious spikes that went way up. What are those, why would those on those dates be that high? Is
So-
that a day where they're crunching the sand? Is that a day?
There's a number of things that can affect air quality. It could be agriculture, it could be transportation. And as far as our work, we haven't been able to definitively say whether or not a mine is contributing this amount of pollution to the air. On these days, we do see increases, and it could be due to agriculture, it could be due to truck traffic, if people are burning leaves, or if there any sort of combustion, that can affect the air quality in the air. But we do see though is an increase in air quality, and that is something, as Alex said, it's not necessarily who causes the increase in air quality, it's the health risks associated with that increase in air quality.
As one, I live across from there, and that was usually windier days. It would be just white.
So is 2.5 attributable to frac sand, or is it attributable to combustion? Because I go back to your first slide.
Yeah, so PM 2.5 particles can be made in the atmosphere from a combination of sources. So you can have fumes from different chemicals, and they can combine in the air to make PM 2.5 particles. It's not essentially what material the particle is made out of, as it is the size of the particle and that effect on the respiratory system. Industrial processes such as crushing, grinding, blasting, aerosolizing these particles by force, that is where the increase in exposure may come from in terms of industrial activities.
Have you done any speciation on the materials collected from your samples?
In terms of crystalline silica, we did an analysis, and we found that about 8 to 12%, we sent 12 filters to the State Lab of Hygiene. They came back and said 8 to 12% of the mass on the filter was crystalline silica. We focus on PM 2.5 as the whole particle size plays a role in your health. It'd be difficult, and funding-wise, it'd be difficult to measure crystalline silica and to base our work on crystalline silica. We focus on the PM 2.5, and with an increase in PM 2.5, you'd expect to see more crystalline silica So if you had a day with 80 microgram per cubic meter of bad air quality, we would expect 8 micrograms to be attributable to crystalline silica, 8 to 12%.
So how did EPA establish that green line, the annual average standard? How did that standard, how was that developed?
Come to place? Yeah, so they have done a number of tests, and as we find out, there necessarily isn't a safe level of exposure. Any increase above background levels, any increase above 0 is going to increase your risk. They deem 12 as a relatively safe number to be exposed to across a year. And so they've done background air quality testing in cities, and they find that around 7 to 8 is the average for just living in an urban city, depending on the city. Again, Eau Claire we had about an average of 5.11. Depending on the size of the city, what's going on in the city, the amount of cars. So they set this 12 microgram average, annual average standard as sort of their bottom limit as what's safe. They have another occupational exposure standard, and I believe that's 35 for a single day. So we kind of focus on the year-to-year standard as it's these long-term exposures that you see those increase in adverse health effects.
When did they set that standard?
It was recently lowered, about 50 years ago, it was lowered from 15 to 12.
Oh,
And it does actually, because the EPA recognized these 5 particles are particularly dangerous, but this has been a standard in the making for decades and decades. Principally, as Orion said, on dirty city studies, where we see elevated levels of PM 2.5, indeed, from a number of different sources, including combustion, and then people having adverse health effects, cardiac effects, and cancer effects.
So when I look at the 12, roughly the 12 highest readings from your monitor, half of those are at an abnormally low background level.
Yes.
What's your observation from the conclusion or any thoughts you have on that?
So the background, we get our background data from the DNR at the DOT science shop a little south of Eau Claire. So it is the closest sort of state or federal agency that does air quality. It's the closest one we can get our hands on. Our equipment is out in the field. It is very close to operations. It's very close to many sources of industry exposure. We would expect, I mean, when you look at the number of mines over here and you look at what goes on sort of in rural and outside of the city, you would expect to see these differences, and we can't necessarily attribute all of it to mining. We don't try to, but we would expect to see an increase. It's very different air up here in New Auburn Bloomer than it is above the DNR sign shop. We've tried to co-locate with the DNR, we've asked to co-locate with the DNR. Dr. Pierce and I had a meeting with them over the summer, and it seems like they are interested in it. They seem to be moving on these purple air monitors as well, testing them alongside their FRM instruments and trying to make the sort of correction factors that we have also tried to make. So it's really promising with these purple air monitors. As far as the difference in our FRM monitors, it really is just a difference in air.
Have you done any measuring close, as close as you can get, and then another one a half a mile away?
And that is the hope.
Simultaneously?
That would be amazing. With the purple air monitors, we would love to see one at half a mile out, one at a mile out, one at a mile and a half out. That would be the holy grail. As far as our equipment that we have now, it's sort of stationary based, and then we get as close as we can. We don't want to go on mining operations property. So we get as close as we can. We provide the best sort of measurements we can with the best data that we have at hand, and that is the DNR sign shop's background levels.
Is that because you don't have more monitors, or to use multiple simultaneous?
That is the hope with purple air. We have purple air monitors, and we'd love to do that moving forward, and we'll kind of get into that with the next steps. As far as with our more stationary monitors, we could do it. The difficulty is having to have them plugged in, having to go and do every 6 days. We follow the EPA 6-day sampling schedule. So every 6 days we would go, put a new filter in, take the old filter out, go back to the lab, do the sort of analysis, and then do that for however long we sampled. It would have been really nice to see how those
Yeah.
at different distances, and it's great that we're doing it now to kind of opening that door at least.
Because I bet you have some people who live nearby that might
Mm-hmm.
give you access to their property.
Yeah. So it's really exciting work, and we're really looking forward. The purple air is, it's going to open some doors. And so now we get to New Auburn, Wisconsin, and I'll just jump right into it. Our average for PM 2.5 was 22.7 micrograms per cubic meter compared to the DNR background levels at that DOT sign shop of 6.57. So at this site, we did see a significant increase in air quality. Our equipment was again here in that green dot, transportation and processing facility, a transportation facility right up here in that red dot, and then about 2 miles, our equipment was about 2 miles north of a processing plant. And so the scale on this one is significantly different. I think we went from 0 to 40 on the other one. This one is 0 to 140 for PM 2.5. And again, our values in blue compared to the DNRs in red, that 12 microgram per cubic meter annual average in green. We have another line up here, that is the 35 microgram per cubic meter standard set for day-to-day exposure. So we do see on a day-to-day basis, it stays below that. However, on these days, and we can keep these in mind,
So,
it is,
so did you check the operation of those two facilities? Because typically, New Auburn facilities will shut down through the winter.
Yep.
Which surprises me if you're gonna attribute that to those two facilities. Were they even operational?
They were year-round. They were year-round. And what we have found also is that in these winter months, there is a stagnant air sort of effect, where the particles, it's similar to an inversion when you have hot air trapping particles with the cold air, you have that.
And there's more wood burning stoves during that period of time too.
Yes, yes. Again, we can't attribute, we're not trying to attribute everything to mining operations. There are a number of sources that PM 2.5 does get an increase from.
Can you go back one slide just
Yep.
for a second? Sorry, 2 slides. I'm not making myself, I'm confused. But on the one slide back where you just were
Yep.
there.
Yep.
There you have 3, okay, there's 3 background ones above the green safe level.
Yep.
Or whatever you call that green level.
Mm-hmm.
Then on the most recent slide you just have now? Okay. so
We have
it's
2,
roughly the same,
3, yeah.
yeah, a couple,
Mm-hmm.
okay.
And at this period, we sampled for 10.5 months from July 2015 to May 2016. So there was a difference. In Bloomer, it was for 2 years, this one for 10.5 months. And there are a number of things that can go into background levels, transportation. And it typically to talk about precipitation and wind effects, typically when Wisconsin has a bad air day, or when a city has a bad air day, Wisconsin itself is having a bad air day. It is sort of a regional thing. It's not sort of a centralized phenomenon. And so we see these spikes right over here. And as I said before, the DNR does not collect PM10 levels. We see the same sort of spikes with PM10, and that is what we'd expect to see. And so given that there's no completely safe level of particulate exposure, they set the 12 microgram per cubic meter standard. Any increase above or below the standard is likely to increase your health risks. In Bloomer, using calculations published in the Harvard 6 City study in the New England Journal of Medicine, we estimate that the loss of life based on increased PM 2.5 levels to be about 1 day per year of residence in Bloomer and about 3 days per year of residence in New Auburn. And we have these publications in the references section. This is using the Wisconsin life expectancy, 249 days for the general population for those 65 and older, and then 41 days per person for the general population, and 73 days for those 65 and older in Bloomer. Again, the Medicare population, those 65 and older, and especially for younger individuals as well, immunocompromised, less developed immune systems, less sort of natural barriers to get these particles out and to sort of prevent adverse health effects. And so we sampled in Albertville, and this kind of speaks towards background levels for May 16, 2017 to June 19, 2018, using all of our equipment over there. We had the pictures of it, the DICOT right here, DPS, Dust Frac 2, which you got right there, and then a Dilos indoor air quality monitor. And we're doing background air quality levels here, so this is providing these background levels before a mine comes, and then if mine breaks down, which they are planned to, we can have these background levels and see how that increase. To see if there is an increase in air quality in that area. So we have our DICOT in gray, the DNR background levels. We took the ones from the DOC Shine Stop again. We want to make sure that our background levels are sort of following a similar trend. And then the DPS in green, and the Dilos in orange. And there are some breaks between these days. This was me and my previous colleagues doing this work, whether it's classes or sort of other situations, not getting every single 6-day sampling period. So this is the EPA's 6-day sampling schedule. And we see some high days over here on our DICOT, and we did some analysis of those filters and found that there was a localized source of combustion. There was soot on the filters, and we can kind of put the pin on that and say this was not just some fluke thing, this was not an instrument error, this was a localized source of combustion that added to our filters.
What would you expect the background levels to be down in Iowa rather than in Eau Claire, where the wind blows all the time and it's real flat and a lot of stuff in the air?
That's outside of my area of expertise. I've only driven through Iowa, so I can't I can't speak to it personally.
But I guess I was speaking of the scenario of much more wind than we and many more days of significant wind and flat agricultural land, lots of opportunity to have dust in the air. What would you expect based on that?
So, given a higher wind concentration, we would generally expect a higher PM10 level, since those are the types of particles that can be carried by the wind. As far as PM2.5 goes, that would depend on the agricultural activity in the area. If there was a higher amount of agriculture or truck traffic or anything going like that, that might increase the 2.5 concentration, but the PM10 would be the only one with the wind direction that we would expect much of a variance with. For that.
And that's the larger ones that the fracking companies want. Right?
Yep, that's the ones
larger
that they
ones?
But the companies want, again, sizes more like 500.
Oh, okay.
500 micrometers,
Okay.
half a millimeter is.
Okay, okay, thank you.
And so this is just a good graph because it shows all of our instruments sort of working with one another. We like to see, given these emitting these days, that they're carrying along similar trends. We would expect the FRM instrument, the DICOT, to be the most reliable instrument. It is considered the gold standard that the EPA would use in FRM instrument. And just making sure that the instruments are running along similar trends, making sure that if they're all spiking, then it's sort of more reliable than having just one spike and saying, hey, what's that guy doing? So. And then using our Dust Frac 2, this is analysis that we've recently done, PM2.5 concentrations for background levels throughout the period. Again, we see these increases in winter months, possibly attributable to stagnant air. There are no mining operations currently going on in Albertville. So this is background levels. And then we have our PM2.5 from our DICOT instrument here. Again, background levels, and we average these over the entire sampling period. So there are spikes, and even if we go back to New Auburn, there are spikes, but we didn't get an average of 120 over the whole period. So it's taking all of our samples and averaging them out.
Yeah, the average, I think, is about 22 in New Auburn.
In New Auburn.
Yep.
Mm-hmm. We have our PM10 data as well. Again, background levels. This is analysis that we've recently done this year. And then some preliminary sampling we've done in Bridge Creek and Augusta. We have our Dust Frac 2. We had all of our instruments out there for about a month period. Again, with school and everything that goes on, we haven't finished the sampling here. We kind of have this to if there's any of you from Augusta or the Bridge Creek area, we would love to find partners in that area. We would love to put a purple air monitor over in that area. There's a number of mines in that location, in that area, and we'd love to get more data and more work to present and to publish and to do some analysis with.
How often
So.
do you calibrate your machines?
So we calibrate them every time we go. We have a field notebook and we calibrate it when we get there. Take the filters out, calibrate it again before we leave, and then we calibrate our dicot to 16.67 for the total flow, 1.67 for the low flow. So the low flow for PM 2.5 is total flow for PM 2.5 and PM 10 for that PM 10 size range. The Dust Track 2 is calibrated to 3 liters per minute. The Purple Air, it's an internal calibration. We've reached out to Purple Air to try and get their specifics on it. Company sort of no can share. So, and then as far as our other instruments, I think these are the only, the DPS for 10 liters a minute. So we do calibrate them before and after sampling, after each sampling period. Yep. Or after each sampling date, I should say. Yeah. So, future plans is to kind of, we've done this before, or in the lab, is to generate a very dirty environment. So we have a motor that runs a spinner. We put some of the sand used for hydraulic fracturing in there, and we generate a very bad air environment within a fume hood. We try and see how well does the purple air match up to a Dust Track 2. We did that, I think it was 2 weeks ago, Dr. Pierce and I, and then one of our colleagues who unfortunately couldn't be here today, generating these bad environments, seeing how 2 instruments, one that's $2,500, one that's $250, how they match up to one another. And then to provide community resources. We have a number of these monitors. We'd love to give them out. We'd love to really empower communities and make this data known. As Leah said, the monitors go real time. If you have internet, you can link them up to the internet so people across communities can look, oh, how's Hickston doing? How's Taylor doing? How's Augusta doing? How's Chippewa doing? And you can communicate along those lines. And then to interpret data and to continue to present the work. So we can see the data if it comes online. A number of these purple air monitors have an SD card, so if you don't have internet or if it can't reach out there, it can still store the data. We get about 1-2 months of data. We can come and do the analysis from our lab in Eau Claire. So it's really doing the analysis, getting the monitors out there, and providing this sort of information out for communities. Because as Dr. Pierce said, we really want to bridge the gap between what is available as far as air quality and what's not available. And I've said it before, it's not our stake to put the pin on who's causing this bad air quality. It's our job as scientists to make sure that these health effects and these increases are sort of quantified and we can make communities and individuals known of it.
If you're not trying to blame it, then why do you call your research? If you're not trying to pin the PM 2.5, why do you call it that?
Because we locate next to these mines. We locate next to the mine.
So I took the data found on the DNR website of frac sand mines and processing plants to make maps just so we could visualize where the mines are found throughout the state. I did a heat kind of map, like instead of like temperature though, I used concentrations of mines. So as you can see, as it goes to a whiter color, that's more heavy concentration of mines in that area. And then I changed it into symbols, just so different way to look at it. So each square is a mine in Wisconsin. As you can see, Eau Claire is right here in the middle. I tried to include more cities on there, but I could not find a layer that had more cities on it, but I'm still looking for that through the GIS online. And then this next map shows the places we want to put purple air monitors so that we could get the data for air quality. These are tentative places. Each purple point is a purple air monitor that we hope to put out there in the field to get that air quality data.
So I guess we have some commonly asked questions, like if whether or not you need electricity with the monitor placed, and Aaliyah kind of addressed that earlier, but you do generally need electricity, but there are inverters and different types of power supplies for that, and some of them even run off of solar. And then can the monitors be placed out in different types of precipitation? They definitely can. They have a nice little shielding on here that protects it from the elements so that it can still obtain that data for you. And then, so it's important to note that the power supply should be mounted in a way that it's not submerged into water or covered by snow so that it can still get the data, the air quality in there, because it's got like a little fan in here that brings air into it so that it can then do laser diffraction. So if you cover that up, it's not going to work properly. And then you kind of want to mount it in a place that's out of the direct sunlight and is away from vents or other localized sources that could attribute to the pollution levels. So if you're trying to get an accurate representation of what's coming from the elements and not from your home or anything like that. Mm-hmm.
Do you guys have any questions, comments?
So do you have a list of localities, specific localities where you'd like to locate these?
Yes, so these are locations that we've kind of been in contact and would like to put monitors. We've reached out to some of the individuals in the area that would like to put monitors in these locations. As you said, as you mentioned, we'd love to do different distances. We work with a number of colleagues, Save the Hills being one of them, and so it's kind of, if we can get different distances, we want to put them in a north, south, east, and west. If we want proof of that, we can do that. It's sort of the ideal sort of holy grail in our eyes would be to put them at different distances, see how this air quality is varied from different distances.
Do you have the ability to zoom in on that map on your screen? Or like right where we are today, zoom in so we can see where those purple spots are, where you'd like to add monitors?
Mm-hmm. And as we get this up, the purple spots are actually folks who stepped up, say they have interest in doing that.
Oh, okay.
But folks in the room, including like Department with Industry, if we can, any opportunity for us to get a better understanding of the distance from the facility, the kinds of air concentration. So folks in the room, if you'd like to, I did bring a sign up, you want more information. If you're living in a situation, you want to get some data, please talk with us. Again, these are very inexpensive. We purchased some from the grant. We'd like to work with you. So if you aren't represented by a purple dot on there, please talk to us. We'd like to get better information.
Yeah, based on your experience and I think your background's in toxicology,
It is.
maybe you would want to talk about the difference between precision and accuracy with these meters, because I can see the precision discussion clearly, but it confuses me on the accuracy, exactly what you're measuring, and though you talk about your overall interest, it just seems like a good correlation that you're only citing these next to sand mines when leaving metal smelters and other, more, known emitters of combustion materials alone.
Yeah. I think you raise a very good point. You're absolutely right. One of our approaches now, we've done a little speciation, and Ryan, I agree with him, knowing how much crystalline silica, which is coming from frac sand facilities.
Could be.
It's true. There's some in agricultural dust. You're absolutely right. So you're right. We're looking at the overall concentration of PM 2.5, which is a combination of combustion sources, reagglomeration of particulate matter, and mechanical sources. Absolutely right. Our next step is to look at the ratios of PM 1, 2.5, and 10. We're trying to find a signature that would say, this is more from an agricultural source, or this is a frac sand facility, or this is a roadway where there's a lot of diesel. All of those, you're exactly right, do contribute to PM 2.5. So our next step is to look at ratios. It's a difficult problem, but and again, we are public health scientists. We're looking at the overall risk. But indeed, if we could find this could be a portion to this source, and this to this source, and this source, in ways we might be able to address those sources.
I'd like to respond to that comment a little bit. There is a lot of concern about the emissions from the frac sand. So I appreciate that you're willing to be next to frac sands to find out in a solid scientific way how much that is a concern. It's not saying that, frac sand is the only emitter. It's just a lot of us are concerned about that, and the way to do that is to study it scientifically. So thank you for doing that.
Yeah.
It's not trying to pick out the frac sand are the only people who emit.
Yeah, I appreciate that. And I think it actually is a fair comparison to take a site right next to a frac sand site and a background site. And that site at the frac sand, there are going to be other contributors, but I think it's at least a first step to say, what is the increase in exposure in dust that we get around a frac sand site? We're pulling out 100 million tons a year. Some of that is getting in the air, and so I think that's a reasonable first step, and speciation would be a really nice way to take the next step, and we're hopeful to do it with these purple air monitors.
Does it matter to my lungs whether it's what the component mixture ratio is, or if it's just 2.5 on my toast?
Well, and I really want to make it clear that we're not seeing levels like China. We're not seeing levels like New Delhi. We're not seeing very, very dangerous levels. We're seeing some elevation in what's in the air around frac sand facilities. And it doesn't, for purposes of, we talked about the New England Journal of Medicine study and other studies where you get dirty cities. So we know we've looked at, well, colleagues have looked at hundreds of thousands of people and see whatever it is, a little more 2.5 means my heart doesn't function quite as well, nor do my lungs. That having been said, crystalline silica is a component of this. We found that it seems like the levels between 8 and 12% are low enough that it's better to look at the complete 2.5. And it's getting into the weeds of this discussion, but crystalline silica is a component. We're concerned about it. We think if we control TM 2.5, we're probably also controlling silica exposure to the public.
I heard you say frac mines, plural, but wasn't your sample group one mine for 2 years and another one for 10.5 months? That's
Yes.
a very small sample to make a broad declaration.
True, our first paper looked at 6 different sites, and granted, it was 24-hour samples at each of these, and you're right. So establishing what Orion affectionately calls the purple grid would give us more information. I do hear that, and I think that's really important. We get a more precise estimation of how much more dust is getting in the air and what that risk might entail. You're absolutely right.
What's that monitor cost?
$219.
Where do I buy one?
Purpleair.com, and I don't get any kickback or anything. It's
Purple what?
I'm sorry, purpleair.com. Yeah.
Thank you.
And they give us a discount when we buy them for community use.
So we're having some technical difficulties with displaying anything other than the presentation. So I'm not sure that we'll be able to show on the big screen.
I mean, you've answered my request. You zoomed in.
Yep, I did that much. We wanted to show you some real-time data of the purple air monitors as well, but doesn't seem like we'll be able to.
Yeah, have you looked at the 4,000 samples that the DNR network has collected around frac sand mine and correlated that with your data over time?
Tom, those are all PM10.
Yep,
Yeah,
yes
those-
they are. But, 2.5 is part of PM10.
You're exactly right. That's right. I think those data are of interest. They're collected, as you know, by mining companies and then sent to the DNR. DNR's not monitoring it, but I agree, that's part of the picture.
Yeah, just correlation.
Yeah, that's actually a nice step. I think we could probably do that in New Auburn because I think New Auburn's providing data. I'm not sure.
Well, those 4,000 samples carry a similar wave trend. It's hard to, all of them are measuring air quality as it moves across the state, and they have a lot of similar, wave functions to them.
Yeah.
They all move together, in other words.
I hear what you're saying.
I guess I still don't understand why you wouldn't, as a high priority, measure at the plant and some distance away where people live. And rather than even using Eau Claire data, use your own data as the reference. Put one a couple miles away and you compare your own data to your own data to see what the increase is by the plant. People don't live at the plant. They live nearby in some cases.
I think
They
that,
don't live at the gate.
I think that would be great, and I would love to work with WISA folks if there's some opportunity for us to even provide confidential access so that a particular company wanted to be a really good neighbor and put a monitor in their facility on the fence line, and at different distances we could kind of address these really important questions.
I mean, the one that's up here in Chippewa Falls, there's a street between the plant and a whole bunch of industrial customers. Has somebody knocked on the door and said, can we put one here?
I did, and EOG said no. So,
You said no?
EOG.
Who's
Yeah.
EOG?
Enron Oil and Gas has a large processing facility here in Chippewa Falls, and I asked if we could work with them, and they said no. So I'm still open to doing it. We've talked with the Wisconsin Industrial Sand Association. It would be great to partner in a way that would answer some of these really important questions.
We will find you one of those places along there that will let you put one of those little gadgets on their property.
We'd love to do that, absolutely, yeah. A business or a homeowner or a facility.
Within the week, I'll call you within the week.
Thank you, I really appreciate that.
It might be interesting to put a monitor in one site, you know, at ground level, 10 feet up and 50 feet up, because you know, stuff like road dirt might stay pretty low, whereas, you know, if you go up 50 feet, maybe you get the small particles that are being carried by the wind.
Yeah, it's certainly possible, but we kind of understand some of the movement of these different particles, and we want to, EPA actually says 2 meter high because it reflects what people are breathing. That's probably the most important height in my own estimation. Any other questions of this work? Just wanted to make it, again, available, the recent paper we have here. If you'd like to sign up for more information, maybe have an interest in putting a monitor near you, your home or business, we'd love to talk with you. And other than that, thank you so much for your attention and for the opportunity to present our work. Appreciate it. Thank you.